Now let's talk about a simple electric circuit. A simple electric circuit. A simple electric circuit has battery as a voltage source. It has a switch for either allowing the current to flow by completing the loop or not. So we have battery, we have a switch in a simple electric circuit. This is our switch. Basically, it's a connected piece of wire. So if you put it here, it means this side and this side are completely connected. So there is electrical conductivity or continuity, as we saw on the other video. So a simple electric circuit simply has a switch like this one, or this one, a switch. It has a resistor like this one. It has a bulb, and we are using light emitting diode as a bulb. Let me use the red one, red LED as a bulb. Here. So when you have a switch, you have a resistor, you have a bulb, you have a voltage source, you have components which formulate a simple electric empty slots here. So we can just put switches here. These are basically just conductors to complete the loop or to complete the circuit or the path. In the future, we will see why do we need these two other extra slots when we have more complex circuits. For now, it doesn't make sense, but just bear with me. So these are basically just switches. So now we have a simple electric circuit. Simple electric circuit, meaning we have positive side of voltage. We have a switch which is now turned on. If I turn on this off the switch, I take it off like this. If I remove this, our circuit, the switch is turned off. So you see the light is not lighting because there is no continuity for current to flow. There is no path for current to follow through because this is not connected. But if I take it back, it's connected. Flow of current is flowing through the resistor to the light emitting diode and back to the negative terminal, and the path is complete. So now this is a simple electric circuit. So to remind you in a simple way, these typical light emitting diodes like the ones you see here, the red, blue, green, these normal light emitting diodes, the typical value of current that they handle is around 20 to 30 milliamps. So it could go below. If it goes below, it's better. But if it goes above, let's say above 30, so 35 going to 40, it might actually destroy the LEDs. So to be on safe side, you have to know what is the current that is allowed for the LED. You can get this from the data sheet. So the manufacturer of this LED has a data sheet where they specify exactly what value of current is supposed to go through it without destroying it. So we could call them power ratings, power rating of an LED. So typically we have 20 to 30 milliamps. If you know that, then you apply the theory, and now you will understand the value of resistor that should be placed here. Because you cannot take any value of resistor and put it here. If you take any value of resistor, the LED might not come up, because you might take a resistor which is bigger, which has a larger value, meaning that the current will be small. Like now, for example, the resistor that we have here is 220 ohms. 220. Look at it. But we have another resistor here, which is 1 kilo ohm, if I remember correctly. And if you see this, look at this intensity, and let's change and put a bigger one to see what happens. If we put this one, you see that now the intensity of LED is very dim. The LED is now dim light. Why? Because we have another resistor which is of a greater or bigger value. This was 220, but this is 1K. So more than 2 times 4. Yeah, so more than 4 times. And that's why the intensity now is low. So we need to use a resistor to control the amount of current that goes through. Of course, if the resistor is too much, if it's very big, then the current becomes very small and our LED might be very, very dim. So it depends on your application.